piecewise function, which you'll see me abbreviate as PWF, it's just a function that's given in pieces. So which function you evaluate depends on what your x value is. Like, let me give you an example. Suppose f of x is going to be one of a list of things. Either it's going to be x squared if, say, x is less than negative 2. Let's say it's going to be 2 minus x if x is greater than or equal to negative 2 but less than 5. And let's say it is 5 minus x cubed if x is greater than or equal to 5. So how do we evaluate this thing? If I wanted to evaluate f of negative 6, well, negative 6 is less than negative 2, right? So it's going to be negative 6 squared, which is 36. So these other two functions don't matter because negative 6 isn't in the domain for those pieces. If I wanted to evaluate f of 0, which function am I going to plug it into? Well, 0 is between negative 2 and 5, so I'm going to calculate it using this function, the middle one. So I've got f of 0 is 2 minus 0, which is 2. If I wanted to evaluate f of 17, well, that's going to be 5 minus 17 cubed, some very large negative number, and I don't know what it is. Alright, what about the ones right on the boundaries? How do I evaluate things like f of negative 2? Well, take a look at this. Which piece is negative 2 in? Since I've got the less than or equal to on this one, it's got to be the middle piece, right? Can't be this piece. So it's got to be 2 minus negative 2, which is 4. If you look at f of 5, that's the other one that's on the gap, that is going to be what? We got to pick the last function instead of the middle one because 5 is in this region, not in this one. So that tells you f of 5 is going to be 5 minus 5 cubed. And I think that's 5 minus 125, so negative 120. So they're not bad to evaluate. Now, suppose we wanted to graph these things. Graphing a piecewise function is like pasting a bunch of graphs together. So let me give you kind of a generic example. Suppose we got a piecewise function that looks like p of x is, let's say it's going to be f of x if x is between negative 8 and 4, negative 8 and negative 4, my mistake, including negative 8, not including negative 4. Let's say it's going to be g of x if x is between negative 4 and 4, inclusive on both ends. And let's say it's going to be h of x if x is in between 4 and 10, not including 4 but including 10. So I've got this thing defined all the way from negative 8 to 10. Alright, let me give you the pictures of what these three functions look like. Here's f of x. So if we only want the part of f of x between negative 8 and 4, I'm only interested in the piece of the graph from here to negative 4, which is about here, right? Now, what do my open and closed circles look like? I'm going from a bracket at negative 8, so that one's going to be closed, and this one's going to be open because I'm going to negative 4 with the parentheses on it. Alright, if you look at your graph of g, it is this one. Now, I only want the part of this graph between negative 4 on the x-axis, which is here, and 4 on the x-axis, which is here. So I only want the part that's in between. H of x is going to be this graph, and I only want the part that is between 4 and 10, so 4 is here. I need an open circle there, closed circle here, and I need this part of the graph that's in between. So the key thing that's first is plot all of these graphs on one screen at the same time. So again, these are the three that we're looking at so far, all in one place. Alright, so plot all those on one graph. If you had the actual functions, you could put them in for y1, y2, and y3. Here's what you get. So you got all three of them on there. They're all different colors. But the point is, we only wanted to keep part of each one of them, right? Like from the red graph, all we wanted was the part in here, right? From the blue graph, all we wanted was this middle part, and from the green graph, all we wanted was this last part. So how do we piece all those together in one graph? If you erase everything but the highlighted graph, we get a graph that looks like this. You notice the pieces don't overlap because we erased all the parts that would. So what we ended up with, you notice the F part, the red part, is only between, looks like -8 and -4, which is what we wanted. So this is f of x, if x is between -8 and -4. G of x, since we go from -4 on that side to 4 on this side, it's g of x if x is in -4 to 4. Alright, and it is h of x if x is in open interval at 4 to closed interval at 10, which is exactly what we wanted.